Hello friends, welcome to C# Intermediate to Advanced tutorial. In this video, we will implement the timer class. The timer class will be invoked by our Windows service. So our timer is a class library project, and it depends on two namespaces. One is threading. This threading namespace is for timer, and other one is system.diagnostics. So this is for Windows Event Logger. Next, in our timer count, so that is the class exposed by our class library, and here we have a private member called timer. So this timer class is from system threading. Next, we have a variable of type integer counter. We will use this counter as a running counter. When timer procedure runs periodically, that procedure will increment this counter, and we will write this incremented counter to the Windows Event Logger. Here is the constructor, and in the constructor we are constructing this timer. In the constructor we are constructing this timer. The first parameter is the run counter, so this is the timer callback. So this will be an object. So if you want to pass some information to the timer procedure, you can pass that here. So at runtime, this object will be available to the callback procedure, or we can say for the timer callback. Here we set it as null. We don't want to pass any parameter. So timer callback doesn't have any parameter. Based on that, the timer will change the behavior. Here timer component simply depends on this counter, and it will keep on incrementing the counter. So we set this second parameter as null. Then this is the due time, and this one is the periodic interval. So we set both as infinite. That means in the initial stage, the timer will not start running this run counter. So since the timeout is infinite, it will not start, or the callback procedure will not get called. So we just created the timer, and it will be in the stopped state. Now let's look at this timer procedure. The timer procedure is run counter. That's what we passed here, run counter. So if you see this timer procedure increments our counter, then it forms a string counter val. In bracket we are specifying the counter value. So counter val in bracket we will specify 1. So this will keep on incrementing periodically, CV1, CV2, CV3, like that. And in that string we make a call to environment.new line. Then we print timestamp as well, date as well as timestamp. So this is the entry we will make to the Windows Event Logger periodically. CV1, CV2, CV3, like that. There will be entries. Also there will be a timestamp entry in the next line. So this is our entry, right? String entry. We formed the string, and if you see here, we are making call to write entry method of the Windows Event Logger. Here we specify the category name, then we give our entry as a second parameter. So Windows event logger will get this dynamically formed string as an entry. Next, we have method start counter as well as stop counter. So in this method, if you see, we are accessing the change method of the timer. When you start counter, or when Windows service makes a call to the start counter method, you can see the access specifier is public. That means external world can call this method. So in our case, the Windows service which we are going to create in next 2 video will make a call to this start counter. So when this start counter method is called, we are changing the timer so that the due time will be 1000 millisecond, that means 1 second. Then periodic interval is 5000 millisecond, that means 5 seconds. So in the stop counter, if you see, the due time is infinite. That means the timer callback procedure will not get called. Why? Because we changed the timer and we specified due time as infinite. That means due time will never reach and the procedure will not get called. So this is the way we are stopping the timer. Forget about this periodic interval. When timer is not started, there is no meaning in a periodic interval. But here if you see, once you start the timer, let's state that the timer is started here. The due time is 1 second, so the timer callback will wait and time elapses. Let's state this is 1 second interval. The procedure will get fired here. After that, it will wait for 5 second interval. Then the timer event get fired. I mean the run counter will get called. So afterwards it will be 5 second interval, and on this interval the procedure will get called. That means every 5 seconds he will get an Windows event logger entry when the timer is running. So if you see here at this stage, we are talking about timer is running and timer is stopped, right? Once we implement Windows service, the timer is running will get hooked to the start method of the service, or when user start when the user starts the service, the timer will run, and when they stop the service will make a call to stop counter and the timer will stop, and you won't see any new entries in the Windows event logger. Alright, now we have the idea of what this timer class will do. Now we will go ahead and create the class library project. Alright, now we will create a class library project. For that, I am clicking File, New, Project. So in Windows Desktop Application, Template Visual C++, Windows Classic Desktop, we changed the IDE to Visual Studio 2017 because in the next coming series we are going to use ASP.NET and MVC courses. So for that we changed the IDE from 2005 to 2017. Here we are choosing class library project, and we will change the location to D drive, temp, and we will set the solution name as service timer. We will give same name for our project as well. So click OK here. Here you have class name, right? We will rename that. Service timer. click yes here. You are renaming a file. Would you like to perform a rename in this project of auto reference? Okay, we will go ahead and state yes, and you can see the name get changed here. So as already told, we will unpin this. So we need system.threading because we need to access timer. We need system.diagnostics because we need to access event logger. Next, in our class, we need to have two members. So we are declaring that here. One is the timer, and you know from where it comes, system.threading. The other one is simply a counter. It's a type of integer, and this is the counter we will increment. We already saw that in the PowerPoint slide. Next, in the constructor, so the constructor is srv counter, and here we are creating the timer component, and you can look at the syntax here or the parameters here. First one is the callback, second one is the object state, and third one is due time, and fourth one is period. So here you are seeing red squiggly because we haven't yet implemented this callback function. Now we will write the callback function, and if you see, the scope here is private, and we already saw this in the PowerPoint slide. We increment the counter is here, it's a private member. After that, we form a string and we write that string to the Windows event logger by making call to write entry method. Next, we have start and stop counter method. Here I'm not typing the code, it will save time. So typing the code will give you intelligence and it may look good, but you will be wasting the time. But when you are writing the code, if you hand code like this, you will get a rich experience. So to avoid wasting your time, I am not typing the code. I keep the code in clipboard, and so that saves a lot of time. All right, here we have start counter. The method here is change, and if you see, we are changing the timer component by calling the change method. So what we pass here is a two parameter, due time and period, which was already used in the construction time as well. If you see here, due time, period. So after the construction, here we are changing it. So the adverse effect here is, let's look at the stop counter. We are changing the timer so that due time goes to infinite. That means the callback procedure here, the callback procedure is run counter, right? It will never get called. Why? Because due time is infinite and it will never elapse. When it never elapses, the callback will never get called. When you are starting the timer, we access the same timer and change that infinite due time to 1 second. That means after this method call, then 1 second is elapsed, the callback procedure will get called. All right, just now we finished writing the code. Now we will build this solution. Here I'm clicking rebuild solution. So rebuild is succeeded, and here we have the DLL project, because we started a class library project, right? We will refer this DLL project in the next video when we are writing the service, I mean the Windows service. That's all here in this video. Thank you for watching. Bye.